All right, here's a good question. It says we're just supposed to do something with percent yield. I guess that's section B there. First, it looks like I have to do the theoretical yield of oxygen. So theoretical just means you have to do stoichiometry. So let's write the formula. So I've got KClO3 yields KCl plus O2. Okay, to balance this, I've got 3 oxygens and 2. Got to do common denominator, so let's put a 2 here. That'll give me 6 oxygens, so I need a 3 there. And then 2 KCl, I better put a 2 right there. I think I'm balanced there. Okay, so now they say 5 grams of this stuff, so the mass is 5 grams. And calculate theoretical yield of oxygen. Okay, so I want to know something about oxygen here. They don't tell me a temperature or a pressure, so, and the answer says grams, so let's maybe go to mass. So I'm going to be starting at a solid. First step is to get to moles. Second step is to cross the river. And third step will be to go back to solids, Dale. Okay, so step 1. I need to take the mass of KClO3 and convert that to moles of KClO3. So moles is equal to mass over molar mass. The mass they give me is 5 grams divided by the molar mass of KClO3. Got to figure that out. So potassium's 3910, chlorine's 3545, and 3 oxygens would be 48, I think. So you add that together, 55, 14, be 22, 2, 6, 8, 12. Let me just check my answer key to see if I'm right. 122.55, yep. So 122.55 grams per mole. Grams cancel. Let's do that on our calculator. 5 divide 122.55. So the number of moles of KClO3 is 0.040799, etc. Moles, keep that number in your calculator. And that is of KClO3. So that's step 1 done. Step 2, I've got to take the moles of KClO3, which I just got, and convert that to moles of, we're going to oxygen. That's what's being asked. This is given. So moles of oxygen. Okay, so I write down what I have, 0.04799 moles of KClO3 multiplied by my ratio. So KClO3 is 2 from there. So 2 moles KClO3, and we're going to oxygen, so 3 moles of oxygen. Moles of KClO3 cancel, so I have to take this number and times it by 3, times 3, divide 2. So I'm at 0.0611995, etc. moles of oxygen. Step 2 done. Okay, step 3, I've got to take the moles of oxygen and convert it to mass of oxygen. So moles is equal to mass over molar mass, and that'll lead to, when you manipulate the formula, mass is equal to moles times molar mass. So the moles are 0.0611995 moles times the molar mass of oxygen. There's 2 oxygens, so it's 32. 32.00 grams per mole. Cancel. Alright, so let's times that number by 32. 1.958. 958. 384, whatever, grams. Okay, sig figs looks like I have 3. So this should be 1.96 grams. Looks like I'm on track. So the theoretical yield of oxygen, 1.96. Then they say give the percent yield if 1.78 is produced. So our percent yield formula is just basically like writing a test. So percent yield, let me just write that. Percent yield is equal to, and this is for question B, is equal to experimentally what you got divided by theoretical, or what you got with stoichiometry, times 100. So experimentally they said, how much do they have? 1.78 they got. So they got a 1.78. They were supposed to get, according to stoichiometry, 1.96 times 100. So I just take and do those. So this will be 1.78 divide 1.96 times 100. 90.81. Oh, let's go 3 sig figs, so 90.8. So I'd give that 90.8% yield. So they're pretty close, right? 100% would be perfect yield. 90.8, yeah, they're fairly close. Then what's the next question say? Calculate the percent error. We're supposed to get 9.11. Okay, so percent error. So to get the percent error, that's another formula. What you do is you take what you got, so the experimental, minus the theoretical, divided by the theoretical, times 100. So experimental, 1.78, minus theoretical is 1.96, divided by theoretical 1.96, times 100. Calculator. Whoops. Okay. Okay. 1.78 minus 1.96 equals, divided by 1.96 equals, times 100. 9.18. Let's call it 9.18%. So that's my percent error. Not a huge error. Let me just check to see if that's right. 9.11 I got. Maybe I typed something in wrong. Anyway, hopefully that helps you with that question. And you might have been confused about the theoretical yield. And what do you do with that? Anytime they want a theoretical yield, they want you to do stoichiometry and figure out what you should get when you do the experiment. And then, was that it? Yeah. What you should get when you get the experiment, when you do the experiment. And then the percent yield is a nice number that says how close to you were that. And that's 90.8. And then how much are you off? That's your percent error. All right, hopefully that helps you with that question.